Hello, geometry students. We're in section 7-2 and we have some new vocabulary. We have similar polygons. Okay, we also have similarity ratio and scale factor. And so our similar polygons, two polygons are similar if and only if their corresponding angles are congruent. And the corresponding side lengths are not necessarily congruent, but they are proportional. Okay, that there is a difference. Okay, so angle A here is congruent, so it does have the exact measure as angle W. Okay, and B has the same exact measure as angle X. D has the exact same measure as angle Z because they are congruent, and angle C has the same measure as angle Y. But what you want to notice is that the side lengths are not congruent, but they are proportional. Okay, 5 times 3 is 15, but 4 times 3 is 12, 7 times 3 is 21, and our 6 times 3 is 18. And that's what it means to be proportional. So there's a scale factor of 3, or a scale factor of 1/3, depending on which way we're going, from the big to the small or small to big. And then we use a symbol here to represent similar. Okay, using a similarity statement. List all pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, using the similarity statement, we have A points to R, B points to S, and C points to T. So triangle ABC is similar to triangle RST. Look back at the picture. ABC, RST. Alright, congruent angles. A is to R, B is to S, and C is to T. And then we can say, go right in order. We have A to B, so all we have to do is look at, these two and say A is to B as R is to S. So there's our first ratio. And then we go right down the order. Then we have B and C compared to S and T. And we finally have A and C compared to R and T. All right, check your progress. Go ahead and pause your video. Okay, it says which is not true, right? So angle GHK, right, is not similar, right, to angle QPR. Now, I believe this should say angle K should be congruent to R. Okay, HK line segment should be similar to QR. Okay. GH divided by PQ should be the same as GK divided by PR. That's true because of corresponding sides and so on. But the angle GHK, which is basically this angle here, should not be similar, right, or congruent, right, to QPR down here because they're not corresponding. Okay, Tan is designing a new menu for the restaurant where he works. Determine whether the size for the new menu is similar to the original menu. If so, write the similarity statement and scale factor. Well, we're going to have the 10 compared to the 12. And then we're going to compare that with the 12 compared to the 14. And they are not similar. And we can tell that because their cross products are different. One gives me a 140 and one gives me a 144. Okay, since all angles of a rectangle are right angles and right angles are congruent, then we have corresponding angles are congruent. Okay, compare corresponding sides. So that's what they did, right? Compared the sides, and then it's not similar. So the menus are not similar. So I made it look like a lot easier than it was. Okay, so we have a new example here. We have 10 is to 8, and 12 is to 9.6. Okay, well, 10 is to 8, as 12 is to 9.6. And lo and behold, 96 is this product, and 96 is that product. Therefore, they are similar. Okay, but what we want to figure out is what is the scale factor, right? The scale factor is going to be the 10 to the 8, or I guess you can say 5 to 4. Okay, all right, let's figure out. Okay, now they do have 4 to 5 because they had it, the scale factor going from the from the bigger to the smaller. Okay. Check your progress. Right? Are the two. Determine whether the size for the new invitations is similar to the original invitations. Okay, scale factor is 1/2. So look at that, right? You have 16, right? And if you multiply it by half, you get 8. If you start with 12 and you multiply it by half, you get 6. That's another way of looking at it. So they are similar. Scale factor is 1/2. From the original to the new, the scale factor would be 2. So if you're going from original to new, which I think is what you should have, we said the scale factor is 2. If we're saying we're going from the new back to the original, then the scale factor would be 1/2. Go ahead and check your answer. Pause the video. Good, not similar. Okay, the reason why it's not similar is we can easily see that 12 compared to 8. Right, so the 12 up top compared to the 8 up top, right, is not the same as the 8 up top compared to the 6. Or sorry, the 8 on the side compared to the 6 on the side. Okay, you can see that by their cross products being different. Right, we have 72 and 64. Or you could say that 12/8 divide the top and bottom by 4, and you get 3/2. And 8/6 divide the top and bottom by 2, and you get 4/3. So they do not reduce down to the same fractions. Right, we're going to use similar figures to find missing measures. The two polygons are similar, and we want to find x. Okay, so x is a side length, CD, and that needs to be corresponding to the TU. So we're going to have x is to 3. Okay, but what we have, we need to find one that has two things here. Well, we have a 6 here, and we have a 4. So we can compare 6 to 4. So we got to go from the 6 on top because we start with the x on top. So 6 is to 4. So there we go. We could say that 4x equals 18. And then we divide by 4 to solve for x. And there we go. And solve for x, you get 9/2. Okay, now we're going to solve for the y. Okay. So we have similar, right? We have 8 compared to the y plus 1. Okay. And we're also going to, we still can use these 6 as the 4. Okay. Nice thing about this is, if you want to, we could compare the 4 to the y plus 1. As long as we set our other ratio as 6 to 8. We could have done it just like the first example. We could have said 8 compared to the y plus 1. And since we have 8 on top, we'd have to put the 6 on top and the 4 on the bottom. But our cross products will be the same. Our cross products will be 48 is equal to 6y plus 6. and then we subtract 6 and we get 42 equals 6y, and then divide by 6 and get 7. Oh, or maybe I can't multiply right. Let's go back and look. Oh, 8 times 4 is not 48. Oh, wow, I'm really bad, kids. Here we go. Let's fix that. 32. And then we're going to subtract 6 and get 26. And then we're going to divide by 6 and we get 26 over 6. And then that gives me 13 over. Divide top and bottom by 2 and you get 3. 13 thirds. If you caught that mistake, awesome. I didn't catch it until I checked the work. Alright, checking your progress. If the two polygons are similar, solve for A. Go ahead and pause your video. Look at A. A is right over here. Right, if you answered 2.4, you are correct. But how do we do that? Well, what we can do is we could say 5 is to 3. Those are known ratios, right? 5 is to 3. And then we can say as 4 is to A. Then we can say 5a is equal to 12. And then we can take 12 divided by 5. And that would be 2 and 2/5, I believe. And 2/5 is 0.4. And there you go, 2.4. The two polygons are similar. Solve for B. B is at the very top, right, with the B minus 6. Go ahead and pause your video. Good. If you got 7.2, you are correct. Let's check this. So we can still do the 5 is to 3 if we want to. 5 is to 3. So we compare these two. And then we can compare these two. 2 compared to B minus 6. We got to put the 2, though, up with the 5 because the 5 started. All right, so 5 is to 3 as 2 is to B minus 6. Then we're going to cross multiply, and we get look like 6 is equal to 5b minus, looks like what, 30. And we're going to add 5b, and then 36/5 is my answer. 36/5 is 7 1/5. And 1/5 ends up being 0.2, so we're good. Okay, perimeters of similar polygons. Okay, if two polygons are similar, then their perimeters are proportional to the scale factor between them. So, if we have polygons ABCD being similar to JKLM, okay, then we have the sum of the four sides, okay, ABCD, divided by the four sides, JK, KL, LM, and MJ, though that fraction is going to be equal to the scale factor all the way across. Okay, let's see an example here. It says find the scale factor of ABCDE to the polygon RSTUV and find the perimeter of each polygon. Okay, so look at what we have here. We know that this side's a 4, so this side has to be a 4. Well, that's helpful. We know they're proportional, so this side has to be a 7. This side has to be 10.5. Right? We know that because of the double tick marks. Right? And then we want to figure out what the side length for ST would be. Okay? And we should be able to figure this all out based on what we know. So let's see what was going to go on. So we have the scale factor being 4 to 7. And the way we figured that out was we have the little 4 to 7. We have a 4 right here. And we're comparing that to the 7 right there. We could also said 7 to 4 was my scale factor if we went from this side back to that side. But they're saying scale factor 4 to 7. Okay, sounds good. So by knowing 4 to 7 is my scale factor, we're going to write a proportion to find the length of DC. 4:7, right, as DC is to 10.5. If you're wondering where that came from, right, we're trying to find the double tick mark right here, okay, on the DC side. So, whoops, right here. Trying to find this distance right here. And we are able to use the 4:7 because that's my scale factor. And we're going to compare that to the DC over the 10.5. All right. So then we can solve that by cross multiplying. And that gives us 42 equals 7 times DC. And then divide by 7. So they don't show the 42 there, but 10.5 times 4 is 42. And then 42 divided by 7 is 6. Okay, so since DC is congruent to AB and AE is congruent to DE, the perimeter of ABCDE is 6, 6, 6 plus 4 plus 4, or 26. Okay, then we have 4:7 as 26 is the blank. This helps me then find the perimeter of the second one. Right, and so we have 4x is equal to 26 times 7, and x equals 45.5. Okay, check your progress. Go ahead and pause your video and find the perimeter of each polygon. All right, so we have the top one being 60. Let's figure out why. So we know this has to be 16. That's nice and simple. This side has to be 8 because over here. And so then we have 16 plus 16 is 32. And then 8 and 8 is 16. And then we have our 12. And then we can add these up. 6 plus 4 is 10. And then 3, 4, 5, 6. There it is, 60. So again, being 60. But the question is then how do we get 45 as the other one? Well, the reason why we can go the other way is we know that we have a scale factor of 6 is to 8. 6 is to 8 can be reduced down, I guess, to say 3 out of 4. Okay, so 3 out of 4. And we're going to compare this to, and the 3 came from the 6, right? So we're going to have an x as my perimeter. 3/4 is my scale factor. X is now going to be representative as my perimeter of my smaller figure. Compare that to 60. And then we're going to have 180 equals 4x. And then divide by 4. And 180 divided by 4 is 45.